So hey guys, welcome back to my YouTube channel. So we have moved on the tutorial 6 of the MySQL playlist. So in this video we will discuss about different MySQL constraints, and total there are 6 types of constraints used in MySQL. So in the previous videos we have covered many queries. We have completed single row functions, multiple row functions, aggregate functions. So now we have moved to the constraints part. So in this video we will talk about constraints. So there are, I will show you MySQL constraints. So total there are 6 type of MySQL constraints which are mainly used in MySQL. So they are primary key. So primary key is a constraint which will just uniquely identify each record in your table, which means that the primary key is just a column, like it is a combination of the constraints. So if it will just uniquely identify your each column or record. And one important thing, that primary key is only unique. So you can't, if I give example, if you have a table of student, and like there are some things like student ID, student name, sports column, or you can say age column, marks column. So out of these, student ID would be the primary key, because you know that every student have a unique ID. It can't be similar for two students or three students, but the other columns value can be same. So we need to keep the student ID column as a primary key because it is unique and it will uniquely identify each record in a table. So this is what a primary key is. Then we have a constraint called as not null. So wait, not null. So not null is just a query which will like ensure that the column does not accept any null values. Like when we create any table, all the values in the starting are null only. MySQL will take all the values as none. But if we provide a constraint which is called as not null, so then the MySQL, like the column which will not accept any of the null values. So this is the use of null, not null. And we will again implement all these constraints in our MySQL server client. So don't worry, I am just giving a basic overview of all the constraints used in MySQL. So other than this, there is also a constraint which is known as unique. So unique will, it is a, like it will just ensure that all the column does not accept duplicate values. Duplicate values in sense, you can say that it will not accept any similar values. Like the column will only have all the values unique. It will not accept any of the duplicate value. So this is the use of unique column. And the fourth is, you can say, check. Check is also a constraint in MySQL. So what check will do? Check will just ensure that a column, that your column or row accepts value within the specified range of values. What I mean to say that when you will provide the check condition, then you will need to put something in check. Like if I say, like I'm just giving an example, like if I say I want to create a table, any student table, but in the table I will say that there are columns like marks, ID, roll number, name, but I want that only entries of that student are possible whose marks is greater than 50. So I can do that during the table creation part by using the check column, by using check constraint. So you will just need to write check, and we will write marks greater than 50. So what it will do, when we will do insertion in the table part, so it will just accept those values only where marks are greater than 50, and if we give any value which is less than 50, then it will automatically not take that value in the column, or you can say table. So this is the use of check. Check is also a very important constraint. Then comes the default. Default constraint. So default is nothing but a constraint which will ensure that the column sets a default value for the empty records. So like empty records, which when we create a table, all the columns and the rows are distinct, or you can say they are empty. So like if we want to give any value during the table creation part only, we can give the values, we can insert the values, but all these things we do after the table creation part. How if I can say that I can give any value during the table part only, the table creation part. So I can do that with the default part. Like I will give example, like if you create any table, like table name is you can say city, and in city you will like city name, city values, like city culture. And if I want that my city name should be like Bangalore, so how can we do that? So for doing that, so for doing that, we can just do like we will write default constraint, and then we can write the city name. So it will just create the table, and it will take the default value of the city name during the table creation part only. So you don't need to repeat it during the insertion part. So this is what default will do. And the sixth and the last is the foreign key. And foreign key. And foreign key is basically used for the referential integrity. Now you will ask what is this word referential integrity? So foreign key will just like it will also act like a primary key constraint only, but it will uniquely identify a row in the other table. Listen to it very carefully. It will uniquely identify a row in the other table. Primary key was uniquely identify record in the same table only, like the table we created. But foreign key will uniquely identify the records or the rows in another table. So what this means that if I have created two tables like student and employee, and if I like the primary key of my student column is student ID, okay, because it would be unique for every student, so it is a primary key. And if I say that I link both the tables, the student and employee, and I also kept a column as student ID in the employee table also. So it will act as a primary key in the student table, but it will act as a foreign key in the employee table. So this is what I'm saying, and this is what referential integrity also means. So it will just uniquely identify all the records in another table, like it was doing in the employee table. So this is like I gave you a basic overview what we do in the what the different SQL constraint means. So now we will move to the command line client and we'll execute each of the constraints. So before that, many of my students or you can say peers are asking that can we work on the MySQL workbench also. So yeah, you can also work on the workbench also. I generally prefer to work on the command line client only. But if you say like I will also show you how the like I have also installed the workbench. So this is I will also provide the link of the MySQL workbench in my description box. So what you need to do when you will open workbench, it will ask like welcome to MySQL workbench. Then you need to click here local instance. So what when we you will click it, it will ask for a password, server password. So when you installed your connection, like when you installed the setup, it was asking a password during the setup part. So you need to write that password only here. Like my password was root only, but like I have installed it many times and I have run it many times, so it will not ask password for me. But when you will log in for the first time, it will ask password. Like here is the password root. You just need to provide the password and then it will automatically open. So if I click, like it will automatically open for me because I have previously run also. So how you work on this? You just need to write the queries, select it like I have correct used the database R, then you can see here action output 1728 0 affected duration, and the table which we are creating from the tutorial 3 tutorial 4. So I will show you that table also. So just select and run. So you can see here also code name, type, size, cost. So all these are the queries in the table I am showing you in the workbench. And like for a sample, if you want to see or a query also, like I will write select name from a table name is agg where type equal to you can say school. Okay, S is capital. And if I run this, you know that the output would be Aran and Hari. So let's see. Yeah, you can see the output is Aran and Hari. So you can also work on MySQL Workbench also, but I generally prefer to work on command client. So for those who were asking me regularly, so yeah, this is the answer. You can also work on the workbench. So we will again move to the command client. So first I will show you how to create a table and providing constraint which is not null. Not null will just do that it will create the values and that values can't accept not null values. They can't be null. So we will again create a simple table. Create. First you need to create a database. Create database. Any name you can give k. Then you need to use k, and then you need to create a table. So I will create table stdr and table you can give. Then I am just giving random columns. You can give any column. Like I will write student ID, and then student ID is int. So now I want to say that my student ID column should not accept any of the null values. So now you can use the not null constraint here. You will just write not null after the data type. Then I will again give like any student name. Then I will write again the data type is varchar. Okay, limit is 20. And then I also want that my student name column should not accept the null values. So I again need to give the not null constraint so that my student column would not accept any of the null values. So if we run this, now let's see, or if we want, like I will run this and if we see, yes, so you can see query okay. So it has been executed, and if we want to see the table stdr, so yeah, you can see here. So you can see null is both no, which means that it will not accept any of the null values. So this is what not null is doing. Both of the columns can't accept null values now. Okay. So this is the not null. Now we can move to the check constraint. So check constraint, I told you that it will, like we can give any of the condition, like I also gave example that marks should be greater than 50, then only that column would be inserted. So we can give any condition, like I will again create, and we need, remember one thing, that we need to create a new table every time for performing these constraints. So you can again give any random name like Hari, any of the name, then again student. I will prefer to use the same column names only, int. So I will again say that not null because I don't want my null values in my student ID column. Then again you can write the same query student name, and that should also be not null. But before that you are supposed to provide the data type. Then again I will write not null. And now if I say that I also want a column which is like you can say age, and it is would be also of integer data type, but I want a condition that when a table is created I only want that age values which are strictly greater than 9 only. So I need to provide the check condition, like I will write check in bracket, you can write age, okay, greater than 9. If we see greater than 9, and if we run this, let's see, yeah, query okay. So now what it will do, like when we insert any values in a table, only that values are be inserted where the age is greater than 9, because I have provided the constraint check, I have written age greater than 9. So only those values can be inserted whose age is greater than 9. So if you again, if we write DSC, the table name is RE. If we see this, you can see, and it will also show that I have not provided null, not null in the age column. I have only provided not null constraint in my these two columns, student ID and student name. So here you can see age is returning null as yes, so that like it will show you that we can insert null values in the age column, but the student ID and student name column will not accept the null values. So if I say that, like I will show you the example, like if I write insert into re values, then I will give any of the ID 13, name is like RN, any name, and now we need to give the age. If I write 8 and if I run this, check constraint RE check is not violated. Insert into RE values, yeah. So you can see here, like when I inserted values into column RE, in the table RE, I first gave my age as 8, but in the constraint we saw that we have given the check constraint and we wrote that age should be greater than 9. So it will accept only those values where age is greater than 9. But I gave 8 here, so it will return an error, like you can see, check constraint RE check is violated, which means that the provided condition in the check constraint has been violated and the insertions in the further table can't be completed. But when I run again the query, insert into my table values, and now I give the age as 10, which is greater than 9. So now there is no problem and the query has been executed. So this is what check is doing. So you can see now we can move to the unique constraint of MySQL. So again, I can write create table name. Again, I am giving any random names, RR student ID. I will again move with the same columns only. Int. So here I want that my student ID values should contain only unique values. They can't be duplicated. So you can use the unique constraint here so that all the values of our student column are unique. It will not take any of the value which is duplicate. Again, you can give many columns, student name, varchar 20, and here you can give not null. So you can see, like in the unique, the student ID column, I provided the unique constraint, but I didn't provided the not null. So it will accept the null values, the student ID column, but it will not accept the duplicate values because I have provided unique. So if we run this, yeah, you can see query okay. If I see the table, so yeah, you can see here the student ID will accept null values, but the key is unique. You can see here UNI, which means that all the unique values will be accepted in our table. No other values can't be executed. Okay, so now we can move to the primary key. So primary key will uniquely identify all the records in our table, and this is the most important constraint which is used in our daily life. So there are also other keys like primary key, you can say candidate key, super key, alternate key. So these key also, like candidate key, will also uniquely identify, but the difference is that the primary key will uniquely identify each record and the candidate key will uniquely identify each row or column. Okay, so this is a difference which interviewers can ask in the HR rounds, or you can say in the interviews. So now we can again create a table S, and if I say again that only student ID int, it would be of int type, and I want to store my, like I don't want null values in my student ID column. So I will write not null, then I will write student name. It should be underscore, otherwise it would give error. Student name, and it should be of varchar type 20. Okay, and I also want that this column should also not accept any null values. Okay, but I also want that my student ID column should be unique because it is the primary key, and you also know that student ID column cannot contain duplicate values because every student would have his own unique ID. So that can't be same now. So you just need to provide the primary key, and in brackets you can write the column which you need to make as your primary key. So I will write student ID is my column, and if we run this query, let's see, yeah, query okay. And if I want to see this table also, I will write again DESCS, and if I run this, let's see. So now you can see the primary key. In the key you can see pri, which means the primary key, and the student ID is the primary column. It will only uniquely identify each records, and all the values in this column are unique. They can't be same. So in the unique, when we executed unique constraint, you can see in the key it was displaying unique because we gave unique, but this time we gave primary, so primary is displaying. So this is how you can create a table. And if you want, like if I want to give multiple primary keys, it is not possible because in a table only one key can be a primary key. So this is also a important concept. I have also seen many people asking this. So the sixth, we will move to the fifth constraint, which is known as default constraint. So default constraint, like it will just ensure the consistency in your data. Like when we sometimes require missing data, or like you can say non-entered values to be set to default value, we can easily use a default constraint in such cases to ensure the column is set to default. So I will also show you the implementation of this. So again, you can write create table, any table, rt. Again, I will write student ID, and I want student ID as of integer, and it should not accept any null value, so not null. And I will say that student name also, student name, again varchar 255 20. It should also not accept null value, so give not null. And then I should say that I want a column like city, and city, it should take values, like I will give the data type first, varchar 20, and I will say that it should take a default value, and default value, like I can give Jaipur, any city. So when we take a default value, and before the insertion, if we see the table, it will defaultly create that column and add in that table. So if I say like default, and if I give like Jaipur in this column, so hopefully it would not give any error. Yeah, it is not giving error. So if I run this also DSCRT, so what this will display, that in the city column, it would automatically display the city Jaipur. So if we run this, yeah, so you can see this. The student ID default is null. Student name default is also null. But in the city, it is displaying Jaipur because I gave default as Jaipur in my city column. So you can see here, city column default is Jaipur. So this is what the city column default value is doing. So default is a very important constraint because you can easily give your values or the unique values during the table creation part only. Okay, so default is Jaipur. So we have done total 5 constraints and implemented all of these. So the last constraint which is left is the foreign key, and foreign key is also an important constraint. So for the foreign key, I said you know what is foreign key. So foreign key, like if we have any column in our table, like if we have two tables, then the first column should contain any of the primary key. So the column, like the first table will contain the primary key, and that primary key in the second table would be the foreign key. Okay, so this is what the primary key is doing. So if I say like I want to create two tables, so like if we create any of the table, create, I am missing table names also because we are creating so much tables. If I say I create a table person, I am creating a random value, or you can say PR. Why to give such a long name? So I will again write like ID is my column, and I want ID as int, and it should be not null. Okay, and if I say that name varchar data type and the size can be of 25, and I also want that this should also be not null, and if I say that age is of int. Okay, so if I run this, but I also want a primary key, so you know that how can we give a primary key. We have executed here, you can see here primary key. So here the primary key would be ID, so you need to give primary key and the column which you need to make as your primary key. So I will give ID, and if I run this, let's see, hopefully it should run. It is giving some error. Create table PR ID int not null varchar. Okay, I got it. I got the error. Yeah. So now, so yeah, it is executed. Actually, I gave primary key spelling wrong. So now you can see the primary key column is the ID column is our primary key. So it would be unique for each of our query. So like if I want, now again we need to create a new table. If I say create table depth, okay. So now we will create a table, again a new table, and we want that the ID column is of primary key. So the ID column in this table, the DEPT table, it would be the foreign key. So it would act as a foreign key in the DEPT column. So this is what we will do. So again you need to give ID int, again not null, okay, and you can give any random columns like DPID. It would be also of int, and you can say not null. I am giving any random columns. You can give any of the column of your. So if I say that d name, if I say varchar, size should be 20. Okay. So now if I want my primary key, that should be. So you can see now that we have created a table DEPT. So the ID column we have taken from the table PR. You can see it is the primary key in this column, and we want that the PR column should be as the ID column should be as the foreign key in our DP table. So I have written, and the primary key in this table would be DPID. You can see DPID, and I have also given name varchar. You can see primary key, and primary key is DPID of this table, and then we need to write this constraint F key. So this is what doing. This is a constraint. Then I have just given a random name. So PR is the table name of my this table PR. Then we need to write the table of the second table, which is DPT, and then we need to write foreign key, and I want my ID column is my foreign key, so we will write foreign key in brackets. We will write again ID because we want that column as our ID column, and then we will write references PRID. References PRID, which it means that, like I will show references PRID. So it is just taking the reference, like it will take the reference from the table column PR and ID. So this is what I am doing, that PRID, like it will just take the value of ID from this table, like you can see ID table, and it will act as a foreign key. So you need to write this like the table which the column which we need to as a foreign key, and then you just need to pass the references. So references PRID, it will just take the reference of that column which is your primary key in the first table. So if I run this, it has run, and if you want to see DESC, the table is depth. So if we run this, so now you can see the ID column. The ID column was in this table also. I will also display the PR table. Okay. So you can see the ID column is primary key in the PR table. You can see here primary key. But in the dev column, it would act as a foreign key. You can see ID and here it is written MUL. MUL means multiple. Multiple because it is acting as a primary key in the PR table and it is acting as a foreign key in the dev table same time. So here it is multiple and you can see DPID. I provided DPID as primary key. You can see here primary key DPID. So it is showing DPID as primary key in the dev table. So this is how foreign key works. Just a simple concept that the column which is the primary key in your first table would act as a foreign key in your second table. You can see here. So this is what foreign key is. So we have implemented all the constraints today. So these are the 6 constraints and we learnt about every constraint in this tutorial. So if you have any of the doubts, you can pin me anytime in my LinkedIn account or you can also comment in the comment box. So in the previous tutorial we have completed all the aggregate functions and in this video we have completed all the constraints in the MySQL. So in the upcoming tutorial, many people were asking like I want to create a roadmap, like what are the videos left in this tutorial. So I will tell you that in the upcoming tutorial, we will move to the TCL commands. TCL commands like transition control language. So we will learn about the commands of TCL in the upcoming tutorial. So this is all for this video. If you like the video, please like, subscribe and share among your friends. So till then, bye bye, goodbye, take care.